Hello students, today we are going to learn about the transformation that is a composite transformation. Let's see the introduction. The composite transformation is also called as composition of transformation. In this, two or more transformations are performed one after the other. Sometimes transformation of composition is equivalent to the single transformation. Sometimes we need to perform two, three transformations at a time, and sometimes the single transformation is also sufficient for the composite transformation. Now, following is the example of transformation, that is a translation which is followed by a reflection. This is the original image which is in brown in color. Now we have to get the reflection of this object in this direction. So what we will do, first of all, we have to move this object here to this location, and then we have to take the reflection of this object. Then we will get this object as output. So here, first we are performing the translation, and then we are performing the reflection. So this is nothing but the composite transformation. Two types of transformation we are using here. Let's see the another example. Now what the composite transformation is? In this, the number of transformation or a sequence of transformation can be combined into a single one, which is called as composition, and the resultant matrix is called as composite matrix. The process of combining is called as concatenation. Suppose we want to perform the rotation about an arbitrary point. Arbitrary point means nothing but the point which is other than the origin. Now, as we have seen the different types of transformation, 2D transformation, we have performed all this transformation along with the origin. Now, if we want to perform the transformation about any arbitrary point, then what happened? We have to perform different types of transformation here. Now here we have considered the rotation about an arbitrary point. Now if we want to perform the rotation about an arbitrary point, first we will translate that point to the origin, and then we rotate that point, and then again we bring that point to the original position after the rotation. So in this way, three sequence of transformation we have performed. First is translation, second is rotation, and then again reverse translation to bring it to the original position. The ordering sequence of these numbers of transformation must not be changed. The output obtained from the previous matrix is multiplied with the new coming matrix. Let's see one example which showing the use of composite transformation. Here we have to scale the object, we have to enlarge the object with respect to the center. So for this, the following sequence of transformation will be performed, and all will be combined to a single one. In the first step, what we will do, we will keep the object at its position in as in figure A. So this is the original object which we have put here. Now this object is not at the origin. So let's bring this object to the origin. So in the second step, what we will do, the object is translated so that its centers coincides with the origin as shown in figure B. Now we bring this object to the origin. Now here, after bringing the object to the origin, we can now free to perform the transformation. Now let's see the third step. In this, now we perform the scaling transformation here. Scaling of an object is done by keeping the object at the origin. So the object must be at the origin if we perform the scaling transformation. Here we will enlarge the object. We are doing here the enlarging of the triangle. So we'll enlarge the object here, and the third step gets over. Now come to the final step. Again, we have to translate that object to the original position. So for translating, for moving the object at the original position, we have to do the translation again. So again, translation is done. This second translation is called as the reverse translation. It will position the object at the origin location. So we will get the object at the original position with the help of reverse translation. In this way, we can perform the enlargement of the object at the arbitrary point, means the object is at other point than the origin. In this way, we can combine two or more transformation together with the help of composite transformation. So this is all about the composite transformation. Thank you.